Ladies and gentlemen, the wait is now over. Just imagine that your printers can now print 3 to 5 times faster than they currently do today. How will that change your business? How will that change your ROI? I'm Mark Franz, Executive Vice President of Raise3D US, and I am so excited to be here with you today to kick off something that you, our customers, and our prospective customers have been asking for years. And that is, how do we speed up 3D printing? And I'm so excited to tell you today that we've come up with that solution. We believe that you are all very familiar with FFF. Without a doubt, with the development of FFF 3D printing, it has become easier and quicker to produce prototypes, to customize products to meet individuals' needs, and to carry out small batch production in situations where traditional manufacturing methods are not competitive. In these situations, regardless of its speed, printing is already the best manufacturing solution for many applications. However, when we increase the size of the batch speeds become the main reason 3D printing is not more widely used in production. If the printer speed could be 3 times faster or more, can you imagine how your small batches could become large batches? Imagine you're doing a small batch production run. If I told you the quantity of printed parts produced could be tripled or even quadrupled with our printers, would you still consider that small batch production? Faster speed with the same reliability, accuracy, and repeatability are hard to reach. But that was a challenge we gave to ourselves a few years ago, and that is the news we are bringing to you today. We are making available to our customers a new technology that will improve the ROI of your Raise3D solutions, thus enhancing your implementation of flexible manufacturing. And what that means for you, our customers, is that it totally changes your ROI and even your business model, as you will see how a small batch production goes to a large batch production. It's extremely exciting technology that we are going to explain to you today about how it works and what you might expect some of these benefits to be for you. We are proud to present the game-changing Hyper FFF technology that accelerates FFF printing process, making the maximum size for batches 3 times to 4 times larger. Let's get right into the technology. We've got a wonderful promotional video, so without any further ado, please join me in watching this video.
Like all technologies, FFF 3D printing started with a vision. Then it was shaped by reality. Also, it was constrained by reality. Manufacturing expects more from FFF printing than just prototyping and production aid. However, humanity's pursuit for evolution is constant. 7 years of insight and vision, continuous observing, experimenting, learning, implementing. We've achieved a goal. A limit has been overcome. Welcome to a new world of flexible manufacturing. A 300% increase in productivity. Design iteration can be up to 3 times faster. A 600% increase in productivity. Tooling production can be 6 times faster, cheaper by keeping it in-house. An 800% increase in productivity. Batch production no longer constrained by cycle time. Flexible manufacturing will level up with FFF printing. The potential of future manufacturing is available now. Hyper FFF, additive productivity.
Well, I hope you enjoyed the video. Now you'll probably want to know more about this technology. All components of our ecosystem play an important role in Hyper FFF technology. The components are specifically optimized to work with Hyper FFF technology because as we speed up the printers, we're going to need new filaments that can also withstand the higher speed and still maintain the high accuracy that users have come to expect from our professional 3D printers. These new filaments also require corresponding slicer software, Idea Maker, and the accompanying ecosystem completed with the necessary printing profiles and print management with Raise Cloud. We will never stop listening to you, our customers, and what your desires are for faster printers, larger printers, and different types of filaments to be printed. We will never stop listening and working on that, but we will never sacrifice reliability and accuracy that you've come to expect with the Raise3D portfolio. But how do we go about making this technology available to you? To answer that, Nick and John will go more into the technical aspects of Hyper FFF and bring a more detailed introduction of the technology to you. So now let's hear from Nick.
Picture a 500% increase in speed for FFF manufacturing. I'm Nick. Today I'm going to introduce the latest technology in our Hyper Speed Upgrade Kit. Raise3D has been a pioneer in flexible manufacturing solutions since 2015. To this day, efficiency remains the top priority when manufacturing. 3D printing has become a staple of flexibility in the manufacturing process by allowing users to offload large portions of work to these machines while also having the ability to design and iterate rapidly. However, the value of flexibility cannot be sufficient to justify the use of 3D printing when you would need to produce a larger batch. That may be changing now. Let's take a look at our current printing speeds. Modern professional fused filament fabrication printers usually run at an extrusion speed of 50 to 80 millimeters per second with an acceleration of 1,000 millimeters per second squared. Higher-end industrial FFF printers usually run at a speed close to 250 millimeters per second with an acceleration of 1,000 to 5,000 millimeters per second squared. This is when using a 0.4 millimeter nozzle and a 0.2 millimeter layer height. Another way to look at this speed is material output, the average weight output per day. A professional printer usually runs at 150 to 200 grams per day, while industrial printers will be closer to running around 600 grams per day. Now, considering the cost, building a professional printing farm with around 20 printers could satisfy the need to produce a few hundred parts per week. But the complexity of managing the space increases as the number of machines increases. On the other hand, with the highest end printers, you may pay more for a decent volume and higher output, but the cost limits you from buying more machines that can allow you to handle different customer needs at the same time. Starting with our RMF series printer, we've been exploring how to break through industrial printers' printing speed limitations. On the RMF, we've achieved over 350 millimeters per second extrusion speed and 10,000 millimeters per second squared acceleration. And we've learned much more about printing at high speeds with various materials. In the meantime, while we've been working on the RMF 500, we began thinking of ways to apply this to our other 3D printers. In particular, how we can further push the boundaries of what the Pro 3 series can do. Now, I'm excited to share with you some of the features of our latest Hyper FFF technology, such as the new Pro Series FFF printers with Hyper FFF technology will run at speeds of 350 millimeters per second and 10,000 millimeters per second squared acceleration. Dual extrusion with active vibration cancellation and auto frequency calibration features. The new Hyperspeed filament line, pure filaments optimized for high-speed extrusion, and the new HyperCore filament line, programmed non-uniform composite printing with industrial top strength and layer bonding strength. Also, fully optimized for hyperspeed printing. And finally, optimized slicing profiles for hyperspeed and HyperCore filaments. We'll start bringing the Hyper FFF to our Pro 3 series. To have access to them, all you need to do is buy and install a Pro 3 series Hyperspeed upgrade kit. The printing speed is then boosted from an average of 50 to 80 millimeters per second to 200 to 350 millimeters per second, and acceleration is boosted from 1,000 millimeters per second squared to 10,000 millimeters per second squared with no loss of accuracy or part quality. Now, I said the Pro 3 series is first, and both for existing customers and new customers. But this disruptive technology is not simply just for the Pro 3 series. We are working to bring it to more printer lines in the future, and we'll always do it in such a way that even our existing customers can also benefit from it. So there's no reason for you to wait to buy a Raise3D printer. When improvements will be available, we'll do our best to make them available to all our existing customers, just like we're doing now for existing Pro 3 series customers. A printer equipped with a hyperspeed upgrade can deliver 800 to 1,000 grams of filament within 24 hours. So typically, any parts under 400 grams will be finished within 12 hours. This means that you can start the part at the end of a workday and likely have it finished the very next day. Furthermore, when looking at batch production, the Hyper FFF technology's increased efficiency becomes even more valuable. We'll show you more details and examples of this with a breakdown of the return on investments later. But for now, let's look at the upgrade kit. The kit includes software upgrades, 2 high flow rate Pro 3 hot ends, a smart auto frequency calibrator, a spool of hyperspeed PLA, and a spool of hyperspeed ABS. Our research team has divided FFF printers' printing speeds into 3 different levels. With the hyperspeed upgrade kit, the Pro 3 series will reach level 2, easily tripling current production speeds, cutting down the print time from tens of hours down to just a few hours. The Pro 3 series' strong and stable frame allows the printer to maintain high dimensional accuracy and excellent surface quality while running at extremely high acceleration and high speeds. Also, the Pro 3's advanced onboard processors allow our engineering team to fully unleash the power of innovative motion planning techniques. We're able to process over 600,000 steps per second to implement the active vibration cancellation algorithm on the Pro 3 series. With the Hyperspeed upgrade kit, the Pro 3 series will become one of the fastest dual extrusion printers on the market. The core of the Hyper FFF technology is the active vibration cancellation algorithm. It will calculate an optimized acceleration pattern and absorb the excessive amount of vibration whenever the printer head is making any high-speed direction change. By measuring the natural frequency of the extruder head, the processor will divide the single acceleration command into 2 equivalent accelerations in order to generate 2 reverse vibration waves which cancel their own vibration during the reverse phase. So the printer head manages to minimize its own friction and shaking using the same hardware. An auto frequency calibrator is included in the kit, so the printer will be able to measure its own frequency and adjust the parameters by itself. With the Pro 3 series' robust construction and stable design, the printer can keep its own frequency for months without shifting. It is recommended that the calibration process be carried out every 2 to 3 months, and a manual calibration process is also included. Now, the printer's motion speed is not the only challenge to solve when printing at hyper speeds. The nature of the materials used must also be taken into account. Currently, most of the filaments available on the market will still hit an invisible volume speed wall, where the speed of extrusion cannot keep up with the speed of extruder motion. In addition to this, the layer bonding strength will also drop gradually when printing and cooling at speeds that are 3 times higher. Now we're asking ourselves, how do we solve this for hyperspeed printing? Here's John to introduce and break down.
Thank you, Nick. Hi, everyone. My name is John, and I'm proud to be part of the team that worked on this project over the last few years at Raise3D. Today, I'm going to share and explain 2 of our brand new filament lines for high-speed printing, the Hyperspeed and the HyperCore filament line. The Hyperspeed line is comprised of the most commonly used filaments such as PLA and ABS, while the HyperCore filament line is oriented towards more professional and industrial filaments such as fiber-reinforced materials. Before we come to the details of the new innovative filament lines, first, let's talk about challenges and difficulties in view of material for high-speed 3D printing. For FFF, the printed part is made by extruding a small amount of molten thermoplastic polymer from a hot nozzle to form each layer. Due to this unique layered fabrication concept, the deposit material line is fused by the residual heat of the material and the pressure of the moving nozzle. For high-speed printing, the filament is rapidly fed into the heat block at a speed of about 10 to 20 mm per second, and the polymer has very little time to melt from solid to molten state. Heat transfer needs time for the polymer to have sufficient flowability, meaning they can flow out of the nozzle smoothly and constantly. If the printing speed is too high, the extruded material line is more like a semi-molten state with a hot shell and a cold core. For example, for PLA printing at 220 degrees Celsius, the core may drop down to 180 degrees Celsius or even lower, which can cause nozzle clogging and poor bonding quality between layers, which is also known as poor Z-direction performance. Increasing extruding temperature only helps melting a little bit, and the high extruding temperature will easily ruin the sharp details of the printed part due to the longer cooling process. The hyperspeed line filament are designed to solve this issue. With optimized and balanced molecular weight, hyperspeed ABS and PLA has higher flowability and a lower heat capacity. We are able to achieve faster melting in the hot end and a faster cooling after the material extruded. As a result, the surface quality of parts printed by hyperspeed filament is smooth and most of the sharp details are kept. Most importantly, with optimized molecular weight, both hyperspeed ABS and PLA show excellent interlayer bonding quality and Z-direction strength. Let's take hyperspeed PLA for example. As seen from the diagram, comparing to premium PLA, even though the hyperspeed PLA is printed 4 times faster, it improves the Z-direction strength by 20% and doubles the Z-direction toughness, while still keeps a similar E modulus strength in X and Y directions. At higher printing speed, with outstanding printing quality, hyperspeed PLA is a great material for prototyping, modeling, and more. ABS usually undergoes unfavored part warpage during the printing without heated chamber. Thus, the hyperspeed ABS is optimized to focus on the stiffness and dimensional stability. With zero warpage and a range of post-processing possibilities, hyperspeed ABS also perfectly suitable for many functional parts. And we don't stop at PLA and ABS. More hyperspeed filaments will soon be released, such as PETG, PC, ASA, ESD-safe filaments, and more. For industrial and end-use parts production and heavy-duty applications such as tooling, jigs and fixture, I would like to introduce the HyperCore filament line. The PPACF is a carbon fiber reinforced composite filament with superior heat resistance, strength, and stiffness. However, high-speed printing of fiber reinforced filament brings many challenges, such as lower flowability and a worse interlayer bonding quality and a quicker wearing out of the nozzle. To solve these challenges, we are using optimized extrusion technology to form a fiber-rich inner core where most of the carbon fibers are well aligned and distributed. During high-speed printing, the outstanding heat conductivity of the carbon fiber-rich core will speed up the filament melting in the hot end. Moreover, thanks to the special fiber distribution, few fibers are embedded on the surface of the filament compared to PPACF, and more residual thermal energy is obtained from the fiber-rich inner core, improving polymer healing and welding process across the interface of adjacent layers and lines. As a result, the HyperCore line filament significantly improves the Z-direction strength, the surface print quality, and also the nozzle lifetime. Here, let's take a look at the comparison between the HyperCore PPACF and the regular one. The regular PPACF loses its Z-direction strength quickly as the printing speed goes up, while the HyperCore PPACF maintains its Z-direction strength. Besides that, HyperCore PPACF also has a higher stiffness with around 8.8 gigapascal in X and Y directions. With Raise3D's non-stop innovation, more customized, pre-programmed, and performance-driven high-speed printing filaments will be released in our HyperCore filament line. The impact of the Hyper FFF is huge. We expect many of you to be able to further complement or even replace your traditional manufacturing methods like injection molding and CNC. And we'll be eager to hear your stories of how this new technology helped your business to grow. Let me hand over to Shelby, who will show you the printing results of the upgrade kit, the impact on the ROI, and the launch timeline.
Thank you, John. Hi, I'm Shelby. After listening to the introduction of the Hyper FFF and the Hyperspeed Upgrade Kit, I bet by now you are all looking forward to seeing the comparison of printing results, productivity improvement, and ROI improvement with this technology. Let me introduce you to them one by one. First of all, regarding the printing results, here is a short video showing the comparison of printing results from the best professional 3D printer currently on the market, our Pro 3, with another Pro 3 with the Hyperspeed Upgrade Kit installed. Throughout the video, you can see that after the upgrade kit of the Pro 3 series printer, the maximum speed can be reached up to 5 times the speed of a Pro 3 series printer without an upgrade. At the same time, high accuracy print quality is guaranteed. Here is another set of data showing how ROIs is significantly improved with Hyper FFF. We prepared 2 sample workpieces and a cost simulation for a first-class professional peer printer, the Pro 3 with the upgrade kit, plastic injection molding, and 5-axis CNC respectively. The simulations are taken for small batch production equal to or below 500 pieces. First, let's look closely at the extent to which FFI printing cost efficiency can be improved with Hyper FFF. In general, when equipped with the upgrade kit, the Pro 3 printers in both tests boost printing speed by 350%, showing significant difference from the first-class professional peer printers. The print time for both samples is reduced by a remarkable 75%, and as a result, the yield rate of both samples will increase up to over 4 times. As the lead time with the Pro 3 printers equipped with the upgrade kit, prototyping and tooling can be expected to be finished by the day or the next day. In contrast, outsourcing to CNC or to 3D printing services usually takes 1 to 2 weeks. In terms of yield, if we deploy 100 printers that continuously run for a year, the total yield is about 92,000 pieces of sample A and 350,000 pieces for sample B. In small batch production, this is a game changer. We take 500 pieces volume as an example. For sample A, a unit cost shrinks from about $46 to around $22, which is roughly a 52% drop. The major improvement comes from the lower machine depreciation cost allocated to each printed part, which is reduced from around $34 to around $11. We are considering a depreciation period of 3 years. Besides, you will benefit from a lead time about 66% shorter, or benefit from the saving investment from deploying only 1/3 of printers as originally planned. The same logic applies to sample B. Machine depreciation per unit is reduced from about $12 to around $3, which is a 74% drop. As a result, the unit cost drops around 44%, from around $21 to $12. In total, the time consumption will reduce from 223 days to 61 days, while the cost will be reduced from $10,608 to $6,022. Okay, Now let's have a head-to-head comparison. Just like how service vendors or manufacturers will consider the decision-making moment. We compare the Hyper FFF with the 5-axis CNC and plastic injection molding. Let's check this out. We acquired tailored production plans for sample B from 2 fabrication centers specializing in the above processes, respectively. Both plans were made according to actual criteria and specific machines, which are expected to generate quite decent efficiency among their kind. Each plan deploys 1 machine for the task, and the plastic injection mold has 1 cavity. Since the price gap between FFF printers and these traditional machines is very distinct, we deploy 5 printers to make the game fairer. Still, the machine investment ratio among FFF printers, plastic injection molding machines, and CNC is about 1 to 2 and 2 to 5. First of all, injection molding requires a fixed 30 days for tooling, although it has extremely high yielding speed with injection and starts. Its minimum lead time for the first yield is always about 30 days. The lead time of both CNC and the Hyper FFF solution increases with volume growth. However, the latter only requires 1/3 of the lead time of CNC for the same volume, which saves 12 days and 63 days respectively for producing 100 pieces and 500 pieces. Secondly, the injection mold tooling costs around $14,000, which is fixed at any volume. It is not as cost efficient as others until the batch volume reaches 500 pieces, where the unit cost reaches a reasonable level of around $28. However, in this scale, the Hyper FFF solution wins with a unit cost of $8. The estimated break-even quantity here is 1,731 pieces, where the unit cost is the same for these 2 processes. While 5-axis CNC shows extremely low cost efficiency with a unit cost of $142, the main reason here is the labor-free nature of FFF printing, as well as much lower machine depreciation cost while having the same yield speed as 5-axis CNC. In total, Hyper FFF solution can complete 500-piece batch production with a much shorter lead time than that of a 5-axis CNC solution, but similar to the plastic injection molding solution. By contrast, Hyper FFF solution results in a full cost of $6,022, while the 5-axis CNC solution costs at least $71,100, not including material and consumable parts. For plastic injection molding, that cost will be at least $4,222. For plastic manufacturing owners, the deployment of such Hyper FFF solution and plastic injection molding costs $33,000 and $64,285 respectively. From the data shown, we can see that the size of the batches in which Hyper FFF is more cost efficient and effective than CNC and plastic injection molding is getting larger. Then you may wonder, where is the limit? And where is the break-even point? 1,000 pieces? 2,000 pieces? It will, of course, depend on each specific case. But we are sure that 3 to 5 times faster speed will definitely have a strong impact. We are eager to know your specific case and help you run the calculations. During our test, we've collaborated with some of our clients to validate the performance of the technology and the upgrade kit. Now, let's find out more details about them.
One of our Hyper FFF pilot users is a PCB supplier, with over 2 million customers worldwide, and 6 highly digitalized manufacturing plants. They established a quick response fabricating center, with over 100 fabrication devices, including 5 Raise3D Pro 3 series printers. The purpose of these Pro 3 series printers was to fulfill functional prototyping, required by customers from the electronics sector. The typical order is for a PCB case weighing 100 to 200 grams per set, assembled from multiple pieces. The length of a single piece can reach from 50 to 300 millimeters. Before implementing the Hyper FFF upgrade, the plan was to process over 200 orders per month, with each order requiring between 1 to 5 printed parts. That meant a maximum capacity of at least 1,000 printed parts every month. On average, each Pro 3 series needed to complete at least 1.3 orders every 24 hours continuously, over a 30-day period. After a short trial period, the user adjusted their business scheme according to the new yield rate. First of all, the center's average lead time for original orders was shortened to 1 to 2 days, down from 3 to 4 days using only one printer. Thus, the company is able to reduce their standard lead time and fulfill more orders every month. Second, the company is able to capture business orders with a requirement for a shorter lead time, and those with higher part volume demand, but with a standard lead time. In conclusion, the center can complete more orders at a much quicker rate, adding value to the service and reaching a much larger target market. Another pilot user is a key player in the renewable energy industry. Its primary plant runs extremely large and complex huge production lines, which annually yield over 100 models of component, with over 190 types of post-assembly processing. One of the key challenges is how to switch and organize these production lines cost-efficiently. Basically, each production line requires a certain set of jigs and fixtures in high volume, as well as at least 400 product mock-ups, for each new line to validate capacity. This means over 290 sets of tools are ordered and fabricated in 1 year. The record is 9 million individual pieces. In total, 2/3 of the year is spent in organizing production, and only the remaining third is spent on production itself. Both costs and lead times heavily compromise the cost efficiency of the plant's operation. Moreover, the plant is already planning to expand its total capacity to surpass 500 production lines by 2025. To fulfill the lead time, the user chose outsourced CNC services to deliver various batches of tools and mock-ups. Each batch has an average lead time of 15 days. Using product mock-ups as an example, the lowest quotation is $20 per piece. In comparison, Pro 3 series with the Hyper FFF upgrade provides a solution, with a cost of $3 per piece. In terms of lead time, 50 units of upgraded Pro 3 series printers only need 2 or 3 days to yield 400 3D printed mock-ups, an amount that is sufficient to test a new production line. Every month, the plant will be able to organize at least 3 new production lines. This means a demand of approximately 1,500 mock-ups, and budget savings of more than $25,000 for a single month. And this doesn't include budget savings from printed tools yet. From a holistic perspective, a print farm of 50 upgraded Pro 3 printers has an investment cost of $330,000. A reasonable print time estimate for the average tool model is 3 hours per piece. In a month and a half, the farm can yield 18,000 tools at a continuous rate. A batch, comprised of the same number of tools, made using CNC services would cost $360,000, meaning the investment would reach its break-even point by this time.
After listening to the introduction and seeing the printing results and ROI comparison, we are sure you are ready to experience the Hyper FFF technology, brought to you by the HyperSpeed Upgrade Kit. Now let's talk about how to get this upgrade kit into your business. The HyperSpeed Upgrade Kit is now available on our website. You can visit www.raise3d.com for more detailed information and place your order.
I am thrilled to inform you that we will be able to offer you the upgrade kit for $6.99 until December 31st, 2022. After that date, the price will go up to $9.99.
A newer version of Idea Maker, compatible with hyperspeed printing, will also be available, and you will be able to download it from our website. If you want to see and experience the HyperSpeed Upgrade Kit for yourself, we invite you to visit our booth at the upcoming FormNext 2022 at Frankfurt Messe in Germany from the 15th to the 18th of November. We will be showcasing the HyperSpeed Upgrade Kit and the printing results. For more information on how to install the Upgrade Kit, please visit our support center for the installation guide. If you have any other inquiries regarding the Hyper FFF technology or the HyperSpeed Upgrade Kit, We encourage you to leave a comment or contact Raise3D directly. Thank you for watching our Raise3D launch event. Come to our website and order the Hyperspeed Upgrade Kit. Stay ahead and benefit from additive productivity today.